5 years, we will see systems like this all over Europe.
In the future, the digital intelligence of the truck will be a new trademark.
I think looking back in 50 years, maybe we would ask yourself, why was it allowed to drive with a manual truck?
Driving modern high-tech trucks evolves around the demands for energy-efficient driving, precision and road safety for drivers and others. Automated driving is no longer science fiction, but is already used in many industries such as logistics and transport. One manufacturer with decades of experience is, among others, Volvo Trucks in Sweden. Pioneering innovations for trucks happen at two fronts. One is on the road. Manufacturers are working on a number of vehicles driving simultaneously as a group. They call this way of driving platooning. Several vehicles follow a leading vehicle, while keeping the exact same speed and distance. Platooning contributes to more safety on the road and more convenient driving. It enables a smoother flow of traffic. Platooning trucks can save up to 10% fuel. This virtual trailer coupling is possible by using radar, cameras and control units which are communicating with each other. Other innovations take place in confined areas such as yards, harbors or deep underground in mines. Here in Kristineberg in Sweden, 1,000 meters deep inside the mine Boliden, trucks face difficult and demanding conditions, such as confined space and darkness, curves and uneven ground. Here, for the first time, autonomous driving truck tested in everyday operations underground. Based on a sensor system of radar and laser, the truck analyzes constantly its surrounding space. Thanks to automated speed, gear shifting and smart logistic, all waiting times and stops are minimized and the productivity has increased.
Digitization plays a role in every kind of mobility and logistics. Think about the autonomous driving car, the autonomous driving truck. We're getting it very soon, maybe sooner than a lot of people are expecting it. So everything, if it is digitized and connected, it can be automated.
There is an increased demand of transportation and mobility in the society driven by urbanization, but also by new customer behaviors, like for instance more online shopping. This is actually going to be a paradigm shift when it comes to logistics. The three technology trends that we talk a lot about here when it comes to automation, connectivity and electrification.
Generally, trucks are operating along the full chain of logistics, delivering goods into the cities, but naturally also bringing goods straight from the point of production. In Brazil, the production of sugarcane is big business, but about 4% of the seedlings for next year's harvest are crushed by manually driven trucks following the harvester. They also damage the soil when entering and leaving the field. This means big losses. Volvo Trucks' innovative prototype is an automated self-steering truck which keeps track with minimal deviation. It digitally synchronizes the speed with the harvester, ensuring a high degree of precision. The driver can accelerate or brake manually, or he can use speed control. This increases the harvest's output and the safety at work for the drivers. Back in the city, operating a big refuse truck in urban areas is challenging. Narrow roads, parking cars and crossing pedestrians present high risks for collision. As part of a research project, a Swedish waste disposal company and Volvo Trucks develop and test this prototype of an automated refuse truck. Basically, the heavy truck follows the refuse collector like a dog in walking pace. When the truck approaches a parked car, it will drive around this car. If encountered by playing children, it will stop automatically. Sensors monitor the environment constantly, providing maximum safety. Big advantage for local authorities, only one refuse collector is needed. Innovation never stops, so how can manufacturers tap the full digital potential for future models? In cooperation with Swedish energy agencies, the manufacturer developed a concept truck with hybrid drive, using a new aerodynamic concept.
We had a very tough target to improve transport efficiency by 50%. And we have not made all the final tests yet, but it seems very promising, all that we have tested so far.
This concept truck runs on diesel when necessary, and it recovers and restores electric energy when recuperating while braking or driving downhill.
We actually try to optimize the truck, so we use a combustion engine when needed. We use electrical engines when we can save fuel.
This way, the fully loaded truck can drive up to 10 kilometers in electric mode when on flat roads or in urban areas, nearly noiseless.
Driving in electric mode, first of all, you cut emissions. It's a special feeling to be in a truck that is driven by electric mode.
Its connected superbrain knows the country like the back of one's hand, constantly analyzing the topography ahead by using GPS and electronic road maps.
With digitalization, we can offer new services like zone management. Through GPS positioning, we can, for instance, turn the vehicle into a low emission mode or zero emission mode in certain areas of the cities.
First of all, every business, every company have to think about what is my strategy, what is my future, my digital vision. If I don't know where to head, if I have no vision for the future, no digital vision, I think you are in big trouble.
Connectivity is actually bringing the possibility to optimize both transport efficiency and resources by actually making efficient traffic flows and also increase, for instance, the utilization of already existing infrastructure.
Today, urban areas and road congestions are tough traffic challenges for drivers, commuters and city planners. More and more cities restrict numbers of vehicles in city centres for environmental reasons. Gothenburg is one of the first cities worldwide which invests large sums into the electrification of buses. Here in Sweden's second largest city, electricity is operating fully electric buses along Route 55 in the crowded city centre.
Electromobility starts with addressing the need to create sustainable cities, reducing emission, reducing noise and so forth. Then of course the bus needs to be able to transport people in a safe way.
The project Electricity is a collaboration of 15 partners from industry, city planners and politics to solve this balancing act.
Urban transport has at the moment the most suitable driving patterns, with low average speed, less energy consumption, frequent start and stop with then high level of energy recuperation and suitable ranges, driving distances that will require less battery capacity.
Without a doubt, the first impression is of nearly complete silence. And, at second glance, one realizes that there are no exhaust fumes at all. The electric and the hybrid buses are charged at the end stops with renewable energy. They have an 80% lower energy consumption than a diesel bus. Thanks to electromobility, bus stops inside public buildings have become reality.
Being able to take the public transport and the bus indoors opens up for new ways of city planning, because we can bring public transport closer to people. We can bring buses in areas where we haven't been able to bring them before, because now they are silent.
Nothing's worse than a still-standing truck. Only a moving truck is a good truck for the haulers, their customers, and for road safety. Digitization has become an important enabler of modern mobility.
So with this connectivity technology, we will be able to reduce the number of unplanned stops. We will be able to reduce service costs, and it will also improve road safety with less trucks standing still on the road.
A look behind the scenes, the Volvo Action Service Centre in Ghent in Belgium. Like spiders in a web, these experts have maintenance data of all connected trucks literally at their fingertips. How does that work? During a journey, a truck driver has a technical problem. After stopping, he presses a button next to the steering wheel and seeks direct assistance. The call will be redirected to one of the multilingual Volvo service centers, also called uptime centers. While speaking, the operator already reads all relevant data from the connected truck, also potential diagnostic trouble codes of the problem.
Well, digitalization for us really means that we can gather the information we need and the data we need in a quicker way. We skip quite some steps, let's say, in the communication flow to make sure that the case handling time and to organize that repair that the driver needs or the truck needs is a lot faster than it used to go.
The operator directly books an appointment for the truck, sending all diagnostic codes and providing spare part numbers to the workshop. The driver gets a call from the operator, who is telling him the locations and the time slot for this planned repair stop. Upon arrival at the workshop, the driver is expected. No time is wasted. Every minute of the road counts. The mechanic is informed, does specific diagnostics, and confirms the remote diagnostics. Thanks to the advanced notification by the service center, the software problem of the truck is fixed right away, and the truck is back on the road again. Regardless of their careful training, each driver drives slightly different when using gears and brakes. So how can a truck avoid unnecessary service stops following a fixed, rigid service plan?
Truck monitoring today means that we leverage data. Big data is the new gold for us. In the past, we needed all data to see what had happened to a vehicle. Today, through digitization, we can predict what will happen to that vehicle tomorrow.
Provided the truck owner has booked this service, the system can inform the center digitally about potential malfunctions. An analyst checks the case and runs remote diagnostics. He identifies an upcoming problem before it will occur. This is called predictive maintenance and will become standard in the digital era.
Today, with the live stream of data, we can really create here centrally actionable tasks for each single truck, appoint and plan a dealership to that repair, create the parts and the diagnostics for that specific vehicle.
Instead of calling the truck in at fixed time intervals, the truck is now asked to see a service center only when it's really necessary. The workshop receives all data from the center to arrange resources as spare parts and repair time.
So we clearly moved from a reactive approach to a proactive approach, which is a very big difference.
This maximizes operation times of trucks, saves resources and minimizes breakdowns on the road.
Digitization means transformation of processes, products and certain services into the digital environment so that we can use it from our mobile phones, for example. Think about the car industry is becoming a mobility industry.
Because each one of these technologies can of course bring a lot of value to mobility of goods and transport on its own, but it's actually when they converge they will radically transform transportation.
Trucks are long-term investments. Naturally, the design and look of a model are important for its sales figures. Conventionally, the cabin design and all its support and safety systems is centered at the driver at work. The general boost of computer performance enables the most complex digital simulations like here in the cabin. So how is digitization adding a new dimension to the design of connected trucks?
The big change that's happening now is that the digitalization is not just part of the process, it's actually moving into the product itself. So we have another area, type of design that we have to deal with, interaction design, immaterial design.
The designer's task is to minimize drivers' distraction and also to maximize information when interacting with the truck in a safe way.
I think design is changing in the way that it's not just about the appearance or perception of a product, it's actually about the experience with a product. And that's something that our designers are having to learn to deal with.
Completely new design options lie ahead. Autonomous driving trucks don't always need a driver who needs a cabin to work in.
Maybe aerodynamics won't be such an important thing, so maybe they can be quite boxy.
Today, trucks typically operate for about 150,000 kilometers a year. Shifting gears at exactly the right moment is an art for professional drivers. Automated manual transmission systems support the driver when shifting gears in split seconds. This means reducing fuel consumption for up to 5%. Fuel efficiency is key for the profitable operation of trucks. Therefore, new trucks are fitted with a cloud-based topographic recognition system. Before a truck even arrives at a hill base, the system has already calculated the best kinetic driving for this hill. And following drivers benefit from these calculations via cloud-based service. Steering a heavy freight truck requires sometimes hard work from the driver. Dynamic steering systems enable nearly effortless and precise steering even when fully loaded. Driving very slowly is electronically supported, which is essential when reversing. Irregular road surfaces or strong side winds are automatically compensated. We talked to a veteran expert of automotive safety about digital systems.
We say 90% of the accidents are caused by human error. And the main cause of this is inattention. Now, inattention could be that you are looking in the wrong direction, you're looking at something else apart from driving, and that's where we come in with support systems to help the driver to stay attentive when driving.
When in danger of colliding with another vehicle, the size and weight of trucks multiplies massively the possible impact.
Well, looking at safety, as a human being, you get tired. Now, if you have digitization and you're checking things, it never gets tired. The computer is running, it is collecting data at all times.
By now, all manufacturers have developed life-saving systems such as collision warning and emergency brakes. And by law, this technology is compulsory now all over Europe for all trucks since 2015.
Well, the emergency brake is really a system where you can see that if the driver is not paying attention to what is happening in front of him.
If the radar and camera-based system recognizes a danger ahead, such as the end of a traffic jam, a pre-warning for the driver is activated. When the driver does not react, a light flashes and a loud alarm alerts him. Finally, the emergency brakes spring automatically into action by decoupling the gearbox and a full brake. This happens in split seconds. It prevents an actual collision, even with speed differences of up to 70 kilometers an hour. For the sake of safety, the industry crashes plenty of real trucks and spares no effort to gain insights for future improvements. But real crash tests of trucks cost a fortune and destroy 1 or 2 trucks each time.
When you're doing physical crash testing, you only see what the final outcome is. And you can film meantime. When you're doing simulations of this, you can zoom in, you can zoom inside the surfaces and see what's actually causing the metal and the other surfaces to crack.
Digitization would save enormous costs and resources. It could save the lives of many crashed trucks and speed up development.
With digital testing, you can easier reach paradigm shifts because you can step away from old designs much faster than what you dare to do with physical testing. And this will of course improve the safety of the truck as a whole much faster.
A daily scene in any city, pedestrians and cyclists with headsets on or using their smartphones while crossing a major street, totally unaware of the moving traffic around them.
Well, the 2017 Volvo safety report is showing that if you're in a truck, accidents are going down. If you're in a car, that's also becoming safer. But the alarming thing is that when it comes to vulnerable road users, we're seeing more accidents with them.
Most accidents are based on human behavior. Visibility, for example, is key to road safety. The manufacturer strives to give drivers digitized co-drivers, smart mirrors, cameras, sensors, radar and laser. These scan 360 degrees of the truck's surrounding in real time.
It's going to take some time and a lot of sensors and some supercomputers to come up to the same level as an attentive human being. An inattentive human being, any computer can do that today.
I'm strongly convinced that mobility is one of the areas where digitizing and digitization is helping us quite a bit to be way more productive than before.
It looks like science fiction, a construction site with little noise and absolutely no diesel fumes. Automation shows great strength when applied to constant tasks in unchanging environments. These hybrid or fully electric load carriers do their job constantly at the same speed. Experts expect a reduction of up to 95% of emissions at construction sites in the future. What lies ahead in the future? Generally, the flow of goods will increase due to booming online shopping and changing consumer behavior. Electrified traffic in urban areas will run the transport of goods, waste and people smoothly and more safely, with less noise and no emissions. Smart IT solutions organize a possibly large number of goods together to minimize the number of vehicles. Automated systems will assist drivers with digitized support and safety systems in real time and 24/7.
Because the machine is not making any mistakes. There are no misunderstandings anymore. And of course, the whole value chain, the whole logistic chain is going to be autonomous.
Manufacturers and experts are confident automation and real-time data will propel the operation of high-tech trucks into a new dimension. What can tomorrow's car already do today? Everyone's talking about digitization and self-drive cars.
We consider the fully automated or autonomous vehicle to be entirely realistic. This is all happening now. It's no longer the future.
Studies by the manufacturers promise a rosy future, but what do things look like in reality? What can tomorrow's car already do today? We're going to show you using the new Mercedes-Benz S-Class as our example. It's always stood for innovation and progress. Karl-Heinz Land, an independent expert on digitization, creates an awareness of the rapidly changing market and the urgency of digital change.
The fact is that digitization, something we're all experiencing even in our private lives, is changing the way things are being produced and the services on offer. That in turn is causing the digital transformation. And this is being called the Fourth Industrial Revolution, which will probably have a more lasting effect on our private and business lives than in the first three revolutions since the invention of the steam engine.
The latest generation of the Mercedes-Benz S-Class, a preview for international motoring journalists, a very special moment. The evolution of intelligent motoring, that's what the Stuttgart car makers are calling this view into the future. At the preview, the international press is not only given information about drive and chassis, but invited to a hands-on experience of the special features of the Mercedes-Benz S-Class. Mercedes has set up a test run especially to simulate realistically critical maneuvers. Engineer Frank-Werner Mohn explains.
Completely free, no problem. Yes, let's make a nice journey, but you see it. What do you see? Oh, sorry! Have a look, I'm on the accelerator. You see it?
Entirely new in the S-Class, we have a system that allows us to recognize very quickly and reliably any vehicles moving across the field of view. We do this with a camera and radar system, which can each recognize the other vehicle. But we use both to be quite sure we get no false positive, and we can react very quickly to avoid an accident.
We will do it a second time, but we will make a little bit different in the maneuver. You say what will happen. Let me know.
I don't know.
What will happen?
We'll crash. We will crash.
Hey, it braked, and when the car was through, the brakes went open. The car behind us was not irritated.
Of course, we've given the new S-Class the very latest in automated driving. We've raised our assist systems to a new level and tried to give the driver all the little helpers needed to make driving even safer and even more comfortable.
These little helpers include the Active Distance Assistant Distronic with the Active Steering Assistant. The two together can support the driver in numerous situations. The Active Lane Change Assistant. In the new S-Class, a light touch on the blinkers, all that's needed to change lanes. The Magic Body Control Chassis with curve function causes this bodywork to tilt by 2.65 degrees towards the inside of the bend, reducing the perceived centrifugal force on the passengers. The Avoidance Steering Assistant can support the driver when pedestrians are recognized within the car's danger zone. The Emergency Stop Assistant with tailback emergency brake function reacts in time before a traffic jam end and can prevent an imminent collision with speeds of up to 100 kilometers an hour.
Step by step and year by year, we're adding new functionality to our systems. This highly automated driving is now for the first time at a point where the driver can get on with other things. This means, of course, putting even more technology into the car in order to safely command all situations.
Other manufacturers are of course researching and developing similar systems on a daily basis. It is a race to digitization to ever more complex vehicles. Audi, BMW or Toyota, and not forgetting Tesla. They're all exploring the field of autonomous driving and hope to have models on the market within a few years. This is precisely what we want to test, so we carjacked the S-Class to the Frankfurt area, one of Germany's major conurbations. We want to find out what the S-Class can do. How pleasant and comfortable is it for the driver? How does the car behave on winding roads? We get someone who knows all about it to explain it to us. Bernhard Weidemann is Daimler's press spokesman for autonomous vehicles and intelligent drive.
When we put this generation of the S-Class on the market in 2013, we introduced the Distronic distance regulator, which also included a steering assistant. It was a distance regulator supported by radar, allowing me to drive as fast as I like, but not faster than the car in front, thus automatically ensuring that I keep my distance. At the same time, as driver, I got this steering support. Another new feature in the S-Class is that we incorporate data from the sat-nav, which are very, very precise into the driving task. If the consumer doesn't trust these mobility systems, he probably won't use them. That's why it's essential that the consumer should have confidence in the services, the products and the companies. Then trust becomes a currency in the digital world. I think this will help us all to introduce the right steps and do the right things to make the systems really digital and safe. Here we're in the driving assistance, and it's getting better and better. It's a bit like a child learning to walk. That's just like us. We learn more and more. In particular, our algorithms keep on improving. The sensory systems are getting better too, so the system we've now got on the market is the best possible at the moment.
This is made possible by faster and faster computers and processors that are more and more powerful. Programmed machine intelligence is already monitoring and controlling our vehicles even today. Let's take a short break to look a bit more closely once more.
The S-Class has a huge number of sensors incorporated. I tried to compare it with a human body. We need our eyes, our ears, to find out what's going on around us. It's much the same with a car. We have these two cameras at the top of the windscreen, which together produce a stereo image, much like our two eyes, so that we have three-dimensional vision. But other cars and pedestrians are also recognized in interaction with the radar. That's located here in front, one of several radar sensors. That's behind here. The advantage of radar is that it's very fast. It works at the speed of light. We've taken advantage of the best of everything, the speed of light with the radar, ultrasound for the hearing, so to speak, all round the car, and of course the camera for seeing.
And the technology will get even better in the future. The keyword is LIDAR. That's a kind of radar using laser beams instead of radio waves.
LIDAR is a system
that works with laser beams, an optical system in other words. It is very exact and very fast. It has a range of well over 100 meters, directional of course, and simply provides a further sensory element which can register distances, speeds and objects around the car very exactly.
Ford see themselves as pioneers in this field. 2005, the first experimental self-drive generation. 2013, the second LIDAR generation. 2016, Ford and Lexus experiment with the latest generation of LIDAR sensors with ranges of up to 200 meters. Different scenes can be registered simultaneously. Waymo, an American company, is also working on the technical development of autonomous cars, continuing the initial tests of the Google streetcar in cooperation with Fiat Chrysler. Long-term, the focus is intended to be on service provision, for example, driverless taxis, not necessarily with driver-owned vehicles.
Who would have thought that we'd be talking about flying cars and self-driving cars, not just in 2040 or 50 in science fiction, but in 2025, 2026. If we combine DNA and digital technology, then we'll have DNA storage. And if we combine car with digital, then we have a self-drive car.
And this too is part of the digitization of mobility. At the Mercedes factory, the new S-Class is already driving itself off the assembly line as a pilot project to start with. Sooner or later, maybe, the cars will be driving themselves to the customer's front door. One thing is certain, our cars will be fundamentally different in the future. Mercedes have taken a look into the automotive crystal ball and created the concept FO15 as a vision of the vehicle of the future. Communicative, eco-friendly and self-driving. This mobility vision will not be for sale though. And another thing, there are legal issues to be resolved. For example, who is liable if a driverless car causes an accident?
Neither we nor the insurers are ruling out the insurability of automated systems in principle. We'll have to assess the risks, of course, which is what insurers do anyway. There'll be discussions about this, but we don't see any fundamental problem.
The first trials of driverless cars in German inner cities are taking place in, for example, Düsseldorf and Berlin. Driverless cars will be negotiating traffic quite soon. The Düsseldorf experiment is due to last 25 months, and the test field is already under preparation. The trials use highly accurate digital maps and reliable communication between the vehicle and technical traffic management. In the USA, permits for autonomous driving have been around for some time. Every major car manufacturer is using the land of boundless opportunity for trial drives. One thing is clear, driverless cars are coming.
We at Mercedes have test licenses on a variety of courses worldwide. With the E-Class, we had the first series model to get a license for driverless testing in Nevada. But we also have test licenses in California and in Germany, close to our R&D locations. And not least, we're building a large testing area close to here in Immendingen, where we'll have opportunities to test every possible scenario independent of road traffic.
We'll encounter more and more of these technical features from innovative concepts on the way to the sustainable robot car. If there are concerns about these visionary technologies, they're due solely to the limited human imagination.
We're working on a fully automated or autonomous vehicle very concretely. It is, of course, the major challenge, but also the ultimate driverless experience, where mobility is made accessible to customers in a completely new fashion. We'll be there in a few years via pilot applications. We'll be seeing small fleets next year already, and we'll get going in a big way in the early 2020s.
Mega cities are one of the major trends of our age. More and more people are moving in more and more confined spaces. Sustainability here means guaranteeing traffic safety all the same. Software-centered motor vehicles are developing more than ever into self-driving digital devices which can seriously improve road safety. But how will this work? And how safe and roadworthy is digitization really? The crucial question is whether car makers and IT companies can cooperate. For example, in data protection and the cybersecurity of driverless cars.
We
have to think about the safety of the total system. If we don't, we're being negligent. If we don't, well, the best thing that could happen would be that as a joke, someone sends my car not to work, but somewhere else, when I should be at work. But it could get nasty if I'm doing 180 and someone takes control of my car and aims it at a concrete pillar. That would probably only happen once. Security is a core issue and one we have to concern ourselves with.
When the S-Class was introduced nearly 50 years ago, in 1972, all of this would have been inconceivable. Since then, the Mercedes-Benz S-Class has been the leader in modern automobile technology and remains so to this day. It has always brought innovations to the marketplace, which went on to become standard in other models too. The next step for the future will be the networked car. Worldwide, the automotive sector is one of the driving forces of the digital transformation. At the latest, since the internet giant Google brought out its driverless vehicle, car manufacturers have picked up the gauntlet. The connected car as an intermediate step towards the self-driving car is currently causing upheavals in the automotive sector.
We at Mercedes have the competences that these new players are bringing onto the market. And as a result of the synergies between the vehicle expertise and the software competence, we think we're in a good position.
Even today, cars have numerous driver assistance systems, but they can't yet alert the drivers to a danger lurking round a bend, for example. Car2X makes more things possible though. Here's a nice example. The virtual warning triangle. Thanks to Car2X, this can be seen much earlier than a physical triangle on the road. Through direct communication with other vehicles in the immediate vicinity, safety-relevant information can quickly be shared.
Car2X already plays a big role for us even today. Last year we were the first manufacturer to integrate it into a production vehicle. The thing about Car2X is that the vehicle sees things that otherwise wouldn't be visible. That means Car2X is a further element towards making driving safer. Whether it's a breakdown or an accident, the driver's told about it before he can see it.
A further advantage of Car2X lies in efficiency enhancement. The continuous exchange of information between all road users allows intelligent traffic control, leading both to fuel economies and time saving. An intelligent networked system can reroute vehicles in the case of a tailback or gridlock. Car2X communication is being tested in research projects both by the automotive sector and by independent research organizations. This will allow the advantages to be tried out and improved on the basis of real-life data. But how future-proof and practical is connectivity in today's cars really?
Many people have the dream of sleeping or just sitting on the back seat when they go on a long drive. We won't be seeing that today or tomorrow. It'll take a bit of time. The next thing we'll see will be fully automated driving in towns.
A vision that may help to avert the threat of total gridlock. Driving in cities is often accompanied by jams, stop and go, or long stops at traffic lights, all of which mean more stress for the driver. But before we get to see fully automated driving in the major cities of our planet, there'll still be occasions when people get driven in special limousines on special occasions. The S-Class, the classic among chauffeur-driven vehicles, is one such eye-catcher. People notice it. We've invited a pro to take the driver's seat. Michael Trux has been a chauffeur for a good 30 years. What he likes about the S-Class is the innovative technology and the unconditional emphasis on passenger comfort.
It offers all the things a passenger expects. In the long version in particular, plenty of legroom in the back seats, and generally a comfortable ride. And of course, it makes an impression on the outside too.
Michael Trux has driven high-ranking politicians such as Henry Kissinger and Mikhail Gorbachev, not to mention VIP actors and sports stars. But his bread and butter in Frankfurt consists rather of prominent bankers. He doesn't yet see autonomous driving as an immediate threat to his line of business.
There are a few assistance systems in the cars already, of course, but really autonomous or even partly autonomous driving, that's still way in the future. In the long term, those occupations where the driver is associated directly with the car may be faced by a certain danger if the driver is replaced by a robot. I don't see that as a serious problem for our trade at the moment, but in some sectors they probably ought to be thinking about what the future holds.
Back to the testing ground. Here's an experimental setup reflecting a daily situation in real life. The end of a traffic queue.
A quite new feature in the S-Class is this emergency braking system it can recognize on the motorway when all the lanes are at a standstill. Maybe the driver's attention has been distracted and he hasn't seen it. The system warns him and performs an emergency stop This system makes a crucial difference to the prevention of rear-end shunts, especially where traffic is queuing.
Frank Werner Mohn can explain this situation very well too.
Tell me, what will happen? Will we crash? It is a soft crash target.
Crash.
Braking!
Braking.
And full brake!
Okay.
Hey!
A little bit scary, really, but everything is okay. It's a very safe experience. It's fantastic and very amazing technique.
And this too is part of the digitization of mobility, the crash test. Mercedes-Benz are working on reconstructing accidents even more realistically, if possible. The aim is to prevent accidents or at least reduce their severity by deploying assistance systems. In the age of intelligent assistance systems and from the perspective of autonomous driving, passive safety, that is to say, mitigating the consequences of an accident for those in the car, is a central task of vehicle development. In just 5 years' time, it's thought we'll be seeing self-driving cars on public roads, especially in our big cities. This is how an autonomous city car could look in 2013, as shown by the Daimler study with the Smart Vision EQ42. The self-driving car can be summoned by smartphone and is thus a potential rival for taxi companies and apps like Uber. It's the first Daimler to dispense with paddles and steering wheel completely. So how close are we really to autonomous driving?
40 or 50 years ago, a car was a piece of mechanical engineering. The value creation came 100% from brakes, clutch, engine, gearbox, etc. And now the car is driving itself. So we have the autonomous car. So probably 70 or 60% of the value creation lies in software. In other words, the software is accounting for more and more of the value. Every business must be aware of this. They have to adapt or die. Survival of the fittest, as Charles Darwin said. The best will survive and the others will go extinct.
So could the digitization of the automobile lead to a transfer of power from human to computer? No final answer can yet be given to this question. But everyone in the business is clear about one thing. When the first self-driving cars appear in our cities, they will have to share the road space with conventional cars with no automated functions. Even so, in the forges where digital ideas are being hammered out, tomorrow's mobility is being developed. It will take greater account of cooperation between all road users and make even today's driving safer, more comfortable and more efficient. For us, modern mobility means reliable and fast internet connection regardless of where we are. This connectivity is provided via satellite, providing broadband internet everywhere, on ships, on planes, and in remote regions of the Earth. Because of digitization, there's an increased need worldwide for broadband internet. Our world is full of network technology. Smartphones are a perfect example. With them, we can go online anytime, any place. We can send photos, videos, stream films and music, find out exactly where we are. What does this mean for us all, technologically and economically? So, digitization of communication, especially satellite communication and geofencing, in other words, we know exactly where an object or a product is, be it a ship, an aircraft, a car, or I myself. And that, of course, changes many things, because I now understand the context. The Luxembourg-based satellite operator SES is the global market leader in this field. SES develops satellites, launches and operates them in space. Currently, the fleet counts over 60 spacecrafts. But how does this internet from space work? To find out more, we set off for the south of the USA. In Florida, the world's largest passenger ship is lying at anchor. And for this ship, the ability to have fast broadband internet is what sets it apart. The ship has broken all manner of records. It's the Harmony of the Seas, operated by Royal Caribbean International. It's not only the world's largest passenger ship, but also enjoys the fastest internet on the high seas. This giant offers its guests more bandwidth than a typical cruise fleet. While the guests relax at sea and enjoy the high-speed internet, IT and satellite experts are working in the background round the clock. While the ship's at sea, a satellite's beam is constantly tracking it, providing the vessel with a cloud of reliable and high-speed internet connection.
We have a spacecraft about 5,000 miles up, actually flying over the ship. Every 40 minutes, the spacecraft flies over the ship. We have 3 antennas that are tracking the satellites, and every time one comes up over the horizon, it starts receiving from the satellite and starts transmitting. Satellite passes over, one antenna flips back and does the same thing again, and they hand over the communications back and forth between the spacecraft.
Cruises are all the rage these days. The number of passengers in Europe alone has doubled in the past 10 years. In North America, numbers are growing just as fast. The Cruise Lines International Association, or CLIA, the largest trade body in the sector, is expecting almost 26 million passengers worldwide in 2017. Cruise operators are investing some $7 billion in new cruise liners. This means new ships and new communications technology. By 2020 already, smartphones will probably account for some 30% of global internet traffic. Millions of interconnected devices will be equipped with the new 5G standard for high-speed internet use. But will the modern ocean cruise ships be able to keep up with the demand of people? The demand to chat, stream live content, and game online. IT experts on modern cruise ships worked just a few years ago with speeds of around 2 to 3 megabits a second. By contrast, the Harmony of the Seas provides speeds of 600 megabits a second. This allows a music album of 600 megabytes to be downloaded in about 8 seconds. And this speed is needed as all 6,000 passengers and 2,000 crew members want online access. It's an impressive example of progress when it comes to providing cruise ships with broadband access.
The first time I saw a guest walking with their iPhone, doing a FaceTime with somebody at home, showing them the whole ship, walking the whole ship and demonstrating the ship to someone at home. And it was no big deal to them, but for us it was a huge undertaking to make that possible.
The main benefit for the guest and crew is that they experience the great internet connection. They are able to post all their memories online on social medias, Facebook, Twitter, Instagram, all these things. They can chat with the family back home to see what they're missing on board and all the great times they have. When it comes to satellite, the connectivity for us is crucial. Nowadays, all the guests and crew members want to experience very fast internet connection. Everybody's so used to it, so it's normal to provide this type of connection on board the ships, cruise ships, as well as they have on land.
People want to be connected everywhere, and for providers, this is top of their agenda. Likewise, it is important for businesses to provide online access to their employees, particularly in remote regions like the world's oceans.
When I first started in the business, I never had kids or anything. Now with the kids, it's been very important for me because there are times, especially during a new build, I'm away from home, a month or so, and that time I could FaceTime with my daughter. When I first started, there was no FaceTime, so I missed the first time she walked. With my son, it's different. He's not 2 years, so now I could see a lot more development while I'm away versus when my daughter was first born. So personally, I think that's been the biggest change for me. Yeah.
Fast broadband access for crew and passengers alike is one of the main goals for cruise operator Royal Caribbean Cruises. That's why the company relies on satellites.
Well, the satellite communication now enables the ships to basically be able to communicate and have different technologies enable us to basically pass on information about the vessel and have efficiencies in communicating that data over to the shore side. And then we have personnel over here making sure that we're being as most efficient as possible. There are definitely some technical challenges where at home you have physical connectivity to your house, and here you have to go to space and then go back to Earth, which is pretty incredible to think about. But the technology is pushing, and we're working with our partners to make sure that that transition between home and cruise is seamless. Royal Caribbean is very interested in making sure that we have crew welfare and that we're taking care of our crew. And our crew and employees, they spend months at a time on the vessels, and they need that special personal touch with their families. So we spend a lot of time and effort to provide that and to make sure that our crew are happy and satisfied.
Digitization is changing the way we communicate and consume. Hence, manufacturers are having to change their product ranges accordingly. It's a far-reaching and permanent transformation. But who's driving this development? We have asked a real digital expert. Industry is making its products and services more digital in order to get closer to consumers. The decisive factor is not how industry wants to offer a product, but the expectations of the customer. So when a customer Googles me on his smartphone, even if I'm a baker and he wants to know where the nearest rolls are, then he can find out instantly from Google Maps. If I don't have a website, I probably won't be found anymore. That's the crucial factor. To that extent, industry and consumers are driving this development in equal measure. Digitization also plays a crucial role in the field of satellite communications, with the latest generation of new high-tech spacecraft being able to do vastly more than traditional satellites. But what can these super satellites really do? We meet the SES Chief Engineer Martin Halliwell at the control center of the satellite fleet.
What we're actually doing here generally is that first of all, as you look around, you'll see that all of this data which is being transmitted back from the various different satellites that we have in orbit. Hundreds of thousands of data points, temperatures, voltages, attitude information, status information of the various different satellites is transmitted down here. And everything is monitored and everything is stored. And so we know exactly what is happening on the satellites in orbit. All the various different personnel who work here are completely au fait with the working of these various different spacecraft. So they understand the subsystems, they understand what has to be done to keep them healthy, to keep them in position in space and to keep them pointed at the Earth correctly. So we man this place 24 hours a day, 7 days per week. This is only one actually of 3 operation centers that we have, and we split up the various different satellites that we have on orbit to be controlled from these various different rooms.
High-performance antennas pointing at the satellites are able to transport the signals back and forth, broadcasting satellite TV to millions of households or providing the customers with high-speed connectivity to the desired spot on Earth. What differences are there between the various satellites up there in space?
Within SES's fleet, we have 2 essentially two types of satellite. We have geostationary satellites, which are orbiting at around about 36,000 kilometers, and we have medium Earth orbit satellites, which are orbiting at around about 8,000 kilometers. And each of these type of satellites has different capabilities. Now, for us, that's very important because we can then offer a whole raft of services to our customers.
But how do these new communication satellites work in contrast to the older ones, and what makes them so unique?
Very simply, every satellite utilizes a certain amount of frequency spectrum. It's allocated to that satellite's use. With the traditional satellites, we could only use that frequency once. We just transmitted that frequency over an area of the Earth. With the high throughput satellites, we can break that frequency up into very small beams, and we can use it again and again and again. Providing the beams are far enough apart from each other, we can take that frequency and we can use it again, and we can use it a third time and a fourth time. So the usage of those frequencies that are allocated can be multiplied many times over. So it becomes far more an efficient use of the spectrum which is made available to us. And if you can do that, then again, that opens up the whole possibilities for data communication and allows us to offer a better price point. It allows us to offer new types of applications. And it's basically the stepping stone to how we go forward for the future for data communications via satellite. When a customer requires a low latency type of service, when he needs to get the satellite signal very quickly to the satellite and back to the ground, we can offer him a medium Earth orbit satellite service. If he needs a point to multi-point distribution over a huge area, a geostationary type of satellite might be a better solution for him.
So where do the super satellites come in? To find out more, we take to the air. Because modern civil aviation is increasingly using high-speed internet from space. We leave the Miami region and fly to the Midwest of the United States. In the USA, internet in aircraft is already widespread. We use our flight to test what's really available. We try to stream a video, and voila, it works. Chicago in the Midwest. Internet via satellite already plays a major role at the city's two airports. But the actual revolution is taking place out of the public eye, in the town of Aurora, 80 kilometers away. Here, the engineers of the global Eagle company are testing the latest generation of aircraft antennae, the ones that make fast internet on board possible. Ironically, the aircraft used for the tests is pretty ancient. A Grumman Albatross dating from 1951, pensioned off from the US Navy.
Well, as a pilot, aviation has always been in my blood, and so it's very exciting to be able to have an opportunity to fly an aircraft like this, and also to develop some of the latest technology that we can prove out on this platform.
For nearly 3 years, the company has been testing a new satellite antenna for use in aircraft. It's now about to enter service. We're the first camera team to be allowed to see the high-tech device.
This is our new antenna that we're testing on board our test aircraft here, the Albatross 1. This antenna is our latest development. It's a triple axis antenna. So this is the difficult piece for aircraft, steering the antenna accurately to point to the satellite in all phases of flight is the challenge. There's also some technical challenges when we're traveling so fast on an aircraft. We have to adjust some of the frequencies to make sure that they arrive at the ground station in appropriate order.
Global Eagle offers a complete internet package for international aviation, from the technology to the content. how far advanced is internet access in aircraft? After all, the number of passengers is growing all the time. Today, worldwide, there are 3.6 billion passenger journeys every year.
Now we are getting into the period where we have very extensive, elaborate technologies on the top of the plane, inside the plane, where you can stream and the plane can actually stream back. So it's incredibly more sophisticated, much like the newest phones. So the people benefiting, those benefiting really went from the elite passenger who could afford to buy in-flight connectivity to now every passenger. So there are airplanes being connected every day that weren't connected the day before.
The passengers profit from the super satellites with their high data flows, while they can send emails, upload and download photos and even stream videos. But engineers enhance the technology for the crew of a plane as well. For example, the jet can be constantly monitored from the ground during the flight.
We've come a long way from the original internet connectivity for airplanes, where it used to be only basic and very expensive. And part of the reason it was expensive is that there was not a lot of bandwidth available for airplanes. Now, pendulum has swung to being this elaborate set of satellites all around the world, connecting to thousands of airplanes around the world. So the cost of the total system has gone down, the cost of the satellite bandwidth has gone down, and the availability of all these systems has become universal.
Technology never stands still. So, we see antenna technology evolving every 5 to 6 years. So this is a second generation antenna. The next step is we're already developing new products for our third generation, which will be more on the flat panel realm. So we will be developing flat panels for both KU and KA band, and we'll be hope to testing those on this aircraft also in the future.
And we're not only talking about those in airplanes, we're also talking about those on the ground, in ships, in commercial shipping for oil tankers, cruise ships, people in remote places in Africa. So this technology advancement has really allowed everybody on the planet to be connected instead of those who can afford it.
An example of internet via satellite in remote areas is the SatMed e-health platform on SES satellites. By using SatMed throughout Africa, local doctors are able to communicate with their colleagues in other parts of the world. Likewise, communities in rural areas are also benefiting from e-education programs delivered by satellite-based internet. It's about much more equal opportunities, for example, by educational offers provided all over the globe. Think of the student at Stanford University or at Aachen University and the other student who sits at Ouagadougou and who can afford the same workshop online. Because communication is less expensive, he can attend that same course at Stanford University, which others are paying with $50,000 per term. This is the democratization of educational power and economical power in the wildest sense. I am strongly convinced of that. Digitization is the chance for a better planet with much more equal opportunities. But where would all these exciting products be without the necessary infrastructure on the ground and in space? This precision technology is provided by the satellite operators. It's a complex technological process for providers if consumers are to be able to communicate digitally anytime, any place. What does this mean for companies today? We simply have to understand where the chances and the risks lie. Every company needs to develop a clear goal to see where and whether it can make a profit from digital technology and where not. Is it enough to integrate a sensor into a product? Or do I have to completely rethink the product, as has happened with keys and tickets? Because here, nothing is like it used to be. Anyone running a business needs to be clear about this. So the slogan must be, adapt or die. It's the survival of the fittest, as Charles Darwin said. The rest will simply die out. In digital evolution, this will probably be even more drastic than in the first, second, and third industrial revolutions. Technology that needs to be usable in space over a period of years has always been very expensive and very complex. Do efficiency and sustainability play a role for satellites of the new generation? And what will they look like in the future?
Will be completely different. The size of the satellites will probably be somewhat smaller, and probably the lifetimes will be somewhat shorter as well. At the moment, a satellite's lifetime is between 15 and 18 years. And so you better pretty much know what your market is. You know, when you decide to build it, it takes 3 years to build it, it takes a year basically to prepare it for launch and to launch it, and then it's there for the next 18 years. So that's an enormous time frame, and things are moving so fast technically now. We believe that that is probably too long, and we would like to shorten that cycle. And if you shorten the cycle, it allows us to use different components, it allows us a different approach to the way that we build and launch satellites today. So I think there's a lot of changes coming, and they're coming very quickly. So my belief is that the next phase of spacecraft that we build will be software defined. It'll be basically a sophisticated digital processor on the satellite which can be changed as and when we require it. So I think the satellites, not in 50 years, but the satellites in the next phase of the procurements that we make in 5 years' time will be completely different from the geostationary satellites that we have today. Things are moving that fast now.
Companies are continuing their work on new super satellites for a network in space to encompass the globe for internet everywhere. The next launches are already scheduled.